Welcome to Pilot 10.02, Biodiversity and Seascape. From bathymetry to biodiversity, Smart API for marine life insight. Despite covering over 70% of our planet, the ocean remains largely unknown. Over 80% of marine biodiversity is unmapped. This leaves scientists and policymakers working in the dark, unable to see the seafloor clearly or predict where marine life thrives or declines. Right now, we rely on limited diver-based surveys like BioBlitz events. They give us some insight, but only in small areas and only at certain times. We still don't have spatial biodiversity maps at scale. Without high-resolution bathymetric data and prediction tools, most of the ocean remains a blind spot for conservation planning. To address the marine data gap, we built a smart solution that integrates three key inputs: bathymetry, seafloor geomorphological features, and biological observations from BioBlitz surveys. These layers are combined and fed into an AI model trained to understand the relationship between seafloor structure and biodiversity patterns. The result? Predictive maps of biomass, Shannon diversity index, and species richness, even in areas we've never directly surveyed. This AI-powered solution transforms scattered observations into full-scale spatial intelligence for ocean planning and conservation. Now, let's see the Biodiversity Classification API in action. First, we open the API interface and click on the POST button. Then, we upload a DEM file. This is our input bathymetric data. Next, we choose the biodiversity index we want to predict: biomass, Shannon index, or richness. After clicking Execute, the system runs the full classification pipeline in the background. Once processing is complete, the predicted biodiversity map is automatically generated and available for download directly to your computer. Let's now look at the result we received from the API. We open the classified GeoTIFF file in a GIS software. First, we view the original DEM. This area is near Haifa Bay in Israel. You can see the detailed bathymetric structure of the seafloor. Then we load the predicted biomass classification. The output is divided into 5 classes, from low to high biomass. Class 1, shown in blue, represents flat and less complex sandy areas. These zones tend to have lower biomass. As we move up the scale, we see red areas representing Class 5, higher biomass zones, often located in more complex habitats like rocky slopes, reef edges, or ridges. This spatial distribution helps us identify biodiversity hotspots that may deserve protection or closer study. Our Biodiversity and Seascape solution is built to serve a wide range of marine stakeholders. First, marine scientists and researchers use the data for biodiversity studies and habitat mapping, allowing deeper understanding of species distribution and ecosystem dynamics. Second, environmental conservation organizations apply the insights to design more effective and targeted marine protection strategies. Third, government agencies rely on the predictions to monitor marine ecosystems and support data-driven policymaking. And finally, fisheries management authorities analyze the results to shape sustainable fishing regulations, ensuring both productivity and long-term ecosystem health. Together, these groups form a powerful network working toward healthier, more resilient oceans.